All right, so today is our review for quiz 3. First up, we are graphing using transformations. You know that we like 5 mark points unless it's the square root function, then we take 4. Again, if it helps you to see the parent function, then draw it in, but not required, and we'd love to see the asymptotes. So first up, this one needs a little reformatting. So if I do a little reshuffling, I can see that this -1 should go in the back, and I need to factor out that 2. So here, absolute value, 2 times, in parentheses, x minus 3, closing my parentheses and absolute value bars, and then taking away 1. So then if I catalog my transformations, I should see that that is a horizontal shrink by 1/2, right? The x values will cut in half, and then 3 to the right and 1 unit down. So 3 right, 1 down. There's my vertex. I'm starting from there, and instead of going over 1 and up 1, I'm going over 1/2 but up 1. Back to my starting point. Instead of going over 2 and up 2, I'm going over half of 2, so over 1 and up 2. Right? Those are the 5 points that I want to see. So now connect the dots. And here is your final draft. So absolute value function with a horizontal shrink, 3 right, 1 down. Okay, next one up. Here we see that that is a square root function, but again, I have to do a little restructuring. I need to factor out that -1/2. So f of x equals big square root. Okay, divide out that -1/2. Leaves behind an x minus, right? 4 divided by a -1/2 is a -8. All of that is still under the root inside the function, and the +1 stays outside. So that negative makes it a horizontal flip, right? It's inside, it's underneath the root. This 1/2 is a horizontal stretch by a factor of 2, so the x values double, and then 8 to the right, 8 to the right, and 1 up. So 8 to the right and 1 up puts me right here. Everything is going to go left because of the horizontal flip, and it's also being stretched by a factor of 2. So instead of going over 1 and up 1, I'm going to go over 2 and up 1, back to that starting point. Instead of going over 4, I'm going to go over 8 and up 2. Okay, and then lastly, instead of going over 9, I double that to make that 18, and then up 3. Right, so my 4 points just fit on the grid. Connect the dots and draw in your square root function. Okay, last one here, we should see that it's exponential. Nothing to reformat in the structure, but that negative that's outside says vertical flip. Okay, the 2 means vertical stretch by a factor of 2, so those y values will double. And then up here, right, attached to the exponent here, that's 3 units to the right. Okay, so for this one, the asymptote is really not moving. So I'm going to leave the asymptote right here, right, since I'm not moving my function up or down. Okay, and then here, I'm going to flip it and stretch it first. So here, if I flip it and stretch it, so here I'm over 2, up 1/4 usually, right? So I'm going to flip it, and that 1/4 becomes 1/2. Okay, my next point is usually 1/1/2, but I'm going to flip it and double that 1/2 to be 1. My next point is usually at 0, 1, but I'm going to flip it and double it and make it 2, right? I'm doubling those vertical distances. Okay, next point would normally be over 1 here, okay? And then up 2, but I need to flip it and double it. So I'm going down 4, okay? And then that last one that I usually plot, right, over 2 and up 4, right? So I flip it and double it to make it 8. So right there. I'm doing this in pencil. It's not my final draft. All right, so that's what it looks like right now, but I still need to shift it 3 units to the right. I've already done the vertical flip and the vertical stretch, right? The Y values got doubled. Now everything 3 to the right. So if I move that point right here, 3 right, 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Okay, there in my bright pink, that is my final draft. Okay, with the vertical flip, vertical stretch by a factor of 2, and everything 3 units to the right. Okay, again, that asymptote stayed at y equals 0. Okay, next skill, can you go backwards? Can you write the transform function from the visual provided? So this first one, we should see that that is exponential. We've only been giving you a base of 2, so 2 to the x. Okay, what else is happening? Here I can see that instead of growing like this, right, it is decaying, right? It's losing value. So that signals to me that there's a horizontal flip. Okay, I can also see that it is stretching away from that y-axis by a factor of 2. So a horizontal stretch by 2, right? The x values, right, have doubled, right? Their distance away from that y-axis has doubled. And then my asymptote is down here at y equals -7. So it's moved 7 units down. All right, so I start with 2 raised to the negative 1/2 x power. That's the horizontal flip. That's the horizontal stretch of 2. And then I take away 7 for it to move down 7 units. Okay, next one. Here, my parent is cubic. So y equals x to the 3rd power. I can see that if this is my anchor position, instead of over 1 up 1, we're over 3 and up 1. So a horizontal stretch by a factor of 3. Okay, and then I can also see that everything is moving 2 right and 1 down. Okay, so then building off of that, I would say inside of parentheses, to show the horizontal stretch, I need to make it the reciprocal, so 1/3. Another layer of parentheses, x minus 2, right, because that needs to move it 2 to the right. Close that second set of parentheses, raise it to the 3rd power, and deduct 1. Take away 1 to make it go down 1 unit. I always like to read it back to make sure I did it all. There's the horizontal stretch by 3, 2 right, 1 down, all looks good. Next up, can you graph quadratic functions in all of the different formats? And I'm saying include at least 5 points, and we're giving you clean intercepts mostly for this one here and this one here. Okay, this one we can graph using transformations. So it's all about identifying the structure and just graphing efficiently, making sure you have at least 5 points on the graph. So this first one here, we see that it's an intercept form, right? Because it's coming at us factored. So the first thing that we know are the x-intercepts. We know that we'll have one at -6, 0, and 2, 0. Okay, let's plot them. All right, so those are the 2 x-intercepts right there. So then if I want my axis of symmetry, I'm looking at the average of these two intercepts. So -6 plus 2 over 2. And -4 over 2 is -2. So I'd say x equals -2. But I'm guessing that most of you could see that just from the graph right here. So there's my mirror line, right? My axis of symmetry. Okay, then if I want my vertex, I know that it's going to have the same x value as that axis of symmetry. So I know it's going to be -2 something, but to get to the y value, I need to plug in the x value of the vertex. So let's say I do it right here. So y equals 1/2 parentheses, -2 plus 6, okay, close parentheses, times -2 minus 2. So I need to know half of 4 times -4. Half of 4 is 2. 2 times -4, we're going to get -8. So my vertex is at -2, -8 right here. All right, that looks good. I also know that that 1/2 right here tells me that there's a vertical shrink of 1/2. So if I wanted more points, I could go over 1, up 1/2, back to that vertex, over 2, instead of up 4, I could go up 2, right here and here, right? I have plenty of points from there, so maybe I stop and just connect my dots. If I want to confirm that that's the y-intercept, I could always plug in a 0 for x and make sure that it outputs a y value of -6. Let's check it. Put in a 0 here and here, right? That product is -12. Cut in half, confirms that -6 right there. Okay, next one is easy peasy because we're used to vertex form at this point. So we can extract our vertex really fast. We know that it's at 4, 6, right 4, up 6. So 4 comma 6. So 4, 1, 2, 3, 4, 5, 6 right there. So then my axis of symmetry would be x equals 4. And it's going to be that vertical line that slices through the vertex. So right here. Okay, let me darken that a little bit. All right, so then I can see that it has that vertical flip and a vertical stretch by 2. So over 1 and down 2. Back to that vertex. Over 2 normally would be up 4, but we're going down. So down 4, get it doubled to make it 8. So over 2 and down 8 puts me right here and right here. I have my 5 points. This is my graph. Now those intercepts are not clear. They won't be integer values. If I asked you to solve for them, you would really just make this y value 0, and you would solve for x by taking the square root, right? That's how you would get to it. You would just have a root in your answer. Okay, last one here is presented in standard form. So here we should recognize that that is ax squared, let me write it, ax squared plus bx plus c. So here if I want to get the x coordinate of my vertex first, x equals -b over 2a. So -1 times -1 over 2 times 1/2. So 1 over 1 is just 1. So the x coordinate of my vertex is 1. Plug in to get the y. So I have 1/2 times 1 squared minus 1 minus 4. So 1/2 of 1, because 1 squared is 1. So I have 1/2 minus 1 minus 4. So I'm going to end up with, here's -1/2, or -1/2, sorry, -1/2, and then minus 4. So -4 and 1/2. All right, so as a coordinate, we would say that that would be at 1, comma, -4 and 1/2. So there's the x coordinate and the y coordinate as my ordered pair right there. So 1 over and down 4.5 puts me right about here. Okay, then my axis of symmetry would be the vertical line, x equals 1. And then that 1/2 right here tells me a vertical shrink by 1/2. So from here, I'm over 1 up 1/2 of 1. So right here and here. Okay, next would be over 2 and up 4, but I cut that in half, so I'm up 2 here and here. Okay, next would be over 3 and up 9, but I cut that in half, and that makes it 4.5. So I'm actually just showing you that I'm going to get nice clean intercepts right here as well. But again, I didn't need them to plot my points. If I wanted to solve them algebraically, I could make this equal to 0, and I could factor this down to see that those x-intercepts would be at -2, 0 and +4, 0. Okay, next skill, we're looking at just factoring. This first expression here has 4 terms to it, so the only way that we can factor that down is by grouping. So we group the first 2 and then the last 2. I look for a GCF. They share an x squared in common, leaving behind an x plus 5 in parentheses. Okay, over here I can divide out a -1, leaving behind that same x plus 5. These match. We can reorganize it as x squared minus 1 times x plus 5. But I'm not done because I recognize this as a difference of 2 squares. So x minus 1 times x plus 1 times x plus 5. Fully factored. Okay, next one here, I have no GCF. I see that it's a more complicated quadratic trinomial. If we use our guess and check method, we know that it has to be a 3x and an x in these first 2 positions to get that 3x squared. Now that 4 has to come from a 1 times a 4. They could both be positive or both be negative, or a 2 times 2. But I need something that's going to get me a sum of -8x. So that tells me that they both have to be minuses then. And I'm looking at what in the outside and inside will get me to a -8x. So if I tried the 4 and the 1 or vice versa, that option is not going to work. It must be the 2's. Because here I would have a -6x and a -2x, which would get me collectively back to that -8x in the middle. So this has to be my factorization right here. All right, last one, C, for this type. Here I'm looking at my expression and I see that they have a GCF. They are all in terms of x, and I have that leading coefficient of -1. So I want to divide out a -x from all 3 terms, leaving behind an x squared minus 16x plus 63. So I have a -x, open up the 2 sets of parentheses, got to be an x and an x. And then I'm trying to think of 2 numbers that multiply to a 63 that add to a -16. This is a basic quadratic trinomial. It's got to be 9 and 7, and they both have to be negatives. That is the full factorization of that expression. All right, flip it over. Let's go to the back. Okay, next skill, can you write an equation with certain information for a quadratic? So here I'm saying that I want it to be in vertex form, passing through this point, so that is the xy, with the vertex of -1, -8. So that's the HK. So my format, right, just to remind you of the structure, y equals a times x minus h, quantity squared, plus k. And I need to figure out what a is. I need to know what the stretch factor is, or if there's any flip. So I'm going to plug in what I have. So 0 for y equals a times x is -3, okay, minus -1, close your parentheses, quantity squared. Subtracting a negative goes to a positive. And then here we have a plus -8, so I'm just going to write that as -8, just like that. Okay, again, I'm trying to solve for the a. So I may just add the 8 to the other side. 8 equals -3 plus 1, so -2 as a quantity squared will be 4a. Okay, divide away that 4, and the a value is 2. So now I'm just rewriting my equation with this vertex and this stretch factor. So f of x equals 2 times x plus 1 as a quantity squared, and then take away 8. Okay, and then can you do the same thing, but now intercept form passes through this point, so xy, with these x-intercepts, 7 and 10, think of that as the p and the q. So again, if I start my equation, I could say, well, y equals a, parentheses, x minus p, parentheses, x minus q. And then plug in what I know. I know that the y value is 27. That equals a times x is -2, and then minus a p-value of 7. Okay, and then -2 minus a q-value of 10. So right now I'm here, I need to find a. So now 27 equals, well, here I'll still have the a, times a -9 times a -12. So 27 equals 108 times a. Divide each side by 108, and we get that our a value is 1/4, 1/4. So here I see that it's a shrink, a vertical shrink of 1/4. F of x is equal to 1/4, parentheses, x minus 7 times x minus 10. So again, I'm leaving it in intercept form, right? I can see what the factors are here that produce those x-intercepts of 7 and 10. Okay, next is just all the different methods for solving quadratics. So solve using the method given, and then simplify any radicals. So first what comes up is solving by taking the square root. So I need to get this part here that's being squared all by itself first. So I'm going to start by subtracting 6 from each side. So 3/2 of x minus 4 quantity squared equals 36. I want to clear my fraction, so I'm going to multiply each side by the reciprocal. Reciprocal is just flipping that fraction. So 2/3 times 3/2 is just 1. And then over here on the right, I need 36 times 2/3. If it helps you to reduce it top down or on the diagonals, 3 goes into itself once, into the 36 12 times. So now I have x minus 4 quantity squared equals 24. Now that I've gotten that square part by itself, now I can solve by taking the square root. So now x minus 4 equals plus or minus. So remember that this was a quantity squared, so it could have been plus or minus squared, right, to get that 24. So I need to represent it as a plus or minus. If I simplify root 24, that's 4 times 6. So 2 root 6. And then I add 4 to the other side. And my answer would just be 4 plus or minus 2 root 6. Okay, solve by factoring. So here I need to recognize that this is really a difference of 2 squares. I can see that this is really 3x as a quantity squared, and this is 7 squared. So I can rewrite that as 3x minus 7 times 3x plus 7, all equal to 0. So here, when I set this equal to 0 and solve, I'm adding 7 and dividing by 3. So x equals 7/3. And here I'd be subtracting 7 and dividing by 3. So negative 7/3. Totally fine if you write that as plus or minus 7/3. Right? I would also take that as 2 1/3, right? Plus or minus 2 1/3. That would be fine also. Okay, next, can you solve by completing the square? So first rule here is get all of the terms with x by itself. So I'm going to add the 10 to the other side. So 2x squared minus 12x is equal to 45. Okay, divide out the coefficient in front of the x squared. So 2 parentheses, x squared minus 6x, close parentheses, equals 45. Now complete the square. So take that negative 6, split it in half, and square it. And we get 9. So now we have 2 times, in parentheses, x squared minus 6x plus 9. Close parentheses equals. Now remember what we did. We created a perfect square trinomial here. It's going to factor into a binomial squared in just a moment. Now on the right-hand side, we have 45, but we have to balance it with what we just added on the left. And we didn't just add 9. We added 2 times 9. So plus 18 on the other side. So now I have 2 times, now I'm going to write it factored, x minus 3 quantity squared, all equal to 63. So now I'm going to divide each side by 2. I'm going to show that work up here where I have a little bit more space. I have x minus 3 quantity squared equals 63 over 2. Now I can solve by taking the square root. Okay, so here I have x minus 3 equals, it's going to be plus or minus, root 63 over root 2, just writing it in that interchangeable format. Okay, which really then becomes x minus 3 equals plus or minus. Root 63 is 9 times 7, so 3 root 7 over root 2. Okay, we don't like the root in the bottom, so we need to rationalize. Multiply by root 2 over root 2. So x minus 3 equals plus or minus 3 root 14 all over 2. And then just add the 3 to the other side. So we end up with 3 plus or minus 3 root 14 all over 2. All right, for some of you, you may be able to get there in fewer steps. I'm just trying to give you a nice, clear pathway of how we work through the problem. Okay, last one is quadratic formula. So here first, I need my equation to be set equal to 0. So I'll subtract that 6 to the other side. X squared minus 2x minus 6 equals 0. So A is 1, B is negative 2, C is negative 6. Okay, plugging into Pythagorean theorem, x equals negative b. So a negative 1 times a negative 2 plus or minus square root b squared, so negative 2 squared, minus 4, a is 1, c is negative 6, all over 2a, 2 times 1. Clean it up. X equals 2 plus or minus the square root of 4. And this, I always point out that this is a place where I commonly see a mistake, a sign error here. So I'm going to point that out so you don't make it. So a negative, positive, negative makes a positive 24, and then all over 2. So x equals 2 plus or minus the square root of 28 all over 2. X equals 2 plus or minus square root of 28. That's 4 times 7, so 2 root 7, and then all over 2. In order to simplify this more, I need something that goes into each of these 3 terms, and they're all divisible by 2. So when I divide each of those terms by 2, I end up with just 1 plus or minus the square root of 7, right? Over 1, we don't usually just write that. So we'll leave it as 1 plus or minus the square root of 7. Okay, last, just returning to piecewise, making sure we remember how to do all things piecewise function. So first, can we graph it, find the domain and range, and then evaluate, and then can we go backwards? So let me slide up to here. All right, so first up here, my first piece is an absolute value function. So right here, I know that I'm left 3 and down 1. So right here. And then I know that I have a vertical shrink of 1/2. So over 1, up 1/2, back to my vertex, over 2, and up 1. All right, I'll give myself all those points. Okay, connect the dots. And then apply the domain restriction. So here I'm saying only between a -9. Make sure these points are where they should be. So it should be right here, and that should be hollow right there. That is where it should actually touch, right there. Okay, to -1. So here's where x is -1. That should be solid right there. So that is my first piece of my function. So only with a domain between -9 and -1 right here. Hollow, solid. Okay, next here I should see that that's a line. My y-intercept is at 1. So 0, 1 right here. And then my slope, this would be -1/2. So down 1 and right 2. Let me give myself a few more points to make sure that I am making it perfect. All right, here is the line, but I'm only taking from an x value where it's equal to 0, so nice and solid here, to an x value here of 6 where it's hollow. And I'm taking this little sliver in between, here to here. Okay, and I usually erase my excess. Okay, and then lastly, this one I need to actually visualize. So this would be on its own, y equals -2 square root x minus 6. I just have to shuffle it so I can see it clearly, where it's square root function, right 6 down 4, right 6 down 4, so right here. Okay, and then it's going to have a vertical flip and a vertical stretch of 2. So over 1 and down 2. Over 4, that 2 gets doubled to be down 4, and it would look like that. So solid, and then veering to the right. All right, so now if I want my domain, what can x be? So here we'd start at the -9, right? It has a value up until we get to 1, -1. Right, so we see that there's a little break right here in the graph between here and here. So we'd say from -9 to -1, parenthesis, bracket, union. Here we would say, hard bracket, 0, and then to infinity because it's going to be continuous in this direction to the right. Okay, my range, if I read it bottom up, right here we're at -infinity, all the way up until we get to -4. Hard bracket on that -4, break in the graph. Here we're at -2, so union with -2, and then it has a value all the way up until we get to +2, where it's hollow. So parenthesis right there. Okay, f of 0. So what is the y value when x is 0? So I see that the y value is 1. And if y is negative 1, so if I go like that, what is the x value? So negative 3, also positive 4. Okay, last skill is, can you write the function backwards? Okay, so if I give you a graph, can you write what the function actually is? Let me slide it to there. So here we should see that that is just a horizontal line. So we would say, well, that is y equals 4, but only between negative 9 and negative 6. It has a value at negative 6, but not at negative 9. Okay, this next one looks like a quadratic, looks like a parabola, opens down, has a horizontal stretch of 2. So I would say first, I'd say negative outside, inside 1/2. Okay, we're left 4 up 1. So x plus 4, close both sets of parentheses, make it squared, and add 1. But only between negative 6 and 0. And it's hollow in both of those locations, so nothing takes a little dash. Okay, last one looks cubic, so x to the 3rd power. But if this is my anchor position, instead of over 1, up 1, it's doubling the vertical, so a vertical stretch by 2. And I see that it's over 1 and down 7. So I should have a 2 on the outside, parentheses, x minus 1, close your parentheses, raise it to the 3rd power, and take away 7. So again, 1 right, down 7, and then that vertical stretch of 2. But only where x is greater than or equal to 0, right there. Right? It's nice and solid in that position. All right, that's our review for this cycle. Have a good rest of your day.